Let's start with a review of data engineering. Data ingestion and storage choices. Which data storage solution is typically used for storing structured data in a relational format? Is it A, relational database, B, database, C, data lake, or D, file system? The answer is A, relational database. Relational databases are designed to store structured data in tables with predefined schemas, making them ideal for structured data storage. What is a common misconception about using a data lake for data storage? Is it A, data lakes are only for structured data, B, data lakes require no data governance, C, data lakes are the same as data warehouses, or D, data lakes automatically optimize data queries? The answer is B, data lakes require no data governance. Why this question may seem a bit tricky. Data lakes are often misunderstood as being suitable for all types of data, without considering the need for data governance and management. A company needs to store large volumes of raw sensor data for future analysis. Which storage solution should they consider? Is it A, relational database, B, database, C, data lake, or D, data warehouse? The answer is C, data lake. Data lakes are ideal for storing large volumes of raw data, allowing for future analysis without predefined schemas. Why might a company choose a NoSQL database over a relational database for their data storage needs? Is it A, NoSQL databases are always faster, B, NoSQL databases are cheaper, C, NoSQL databases require no maintenance, or D, NoSQL databases offer better scalability for unstructured data? The answer is D, NoSQL databases offer better scalability for unstructured data. Why this question may seem a bit tricky. NoSQL databases are often chosen for their flexibility and scalability, which can be misunderstood as universally better than relational databases. A startup is building a real-time analytics platform and needs to ingest and store streaming data efficiently. Which technology should they consider? Is it A, relational database, B, database, C, data lake, or D, file system? The answer is B, database. NoSQL databases are well suited for real-time data ingestion and storage due to their scalability and flexibility. Which data storage solution is best suited for storing unstructured data? Is it A, relational database, B, data lake, C, data warehouse, or D, database? The answer is B, data lake. Unstructured data is best stored in a data lake, which can handle various data types without requiring a predefined schema. What is a common misconception about using a NoSQL database for data storage? Is it A, they are only suitable for small datasets, B, they cannot handle structured data, C, they are completely schemaless, or D, they are always faster than relational databases? The answer is C, they are completely schemaless. Why this question may seem a bit tricky. NoSQL databases are often thought to be schemaless, but they do have flexible schemas that can evolve over time.
Have you noticed the code in the bottom corner? Next time you're stumped, take that code to birdsy.ai for immediate help and a free study session with Birdsy, your personal AI study partner. Plus, you'll get access to hundreds of additional questions, helping you move closer to passing your exam with confidence. The next time you're feeling unsure or stuck, give it a try.
A retail company wants to analyze customer purchase patterns in real time. Which data storage solution should they use? Is it A, data warehouse, B, data lake, C, relational database, or D, stream processing platform? The answer is D, stream processing platform. For real-time analytics, a data stream processing platform like Apache Kafka is suitable as it can handle continuous data flow efficiently. Which technology is commonly used for batch processing of large datasets? Is it A, Hadoop, B, Kafka, C, Elasticsearch, or D, Cassandra? The answer is A, Hadoop. Hadoop is a popular framework for batch processing large datasets due to its distributed computing capabilities. A financial institution needs to store transaction data with ACID compliance. Which storage solution should they choose? Is it A, data lake, B, database, C, relational database, or D, data warehouse? The answer is C, relational database. Relational databases provide ACID compliance, which is essential for transaction data to ensure data integrity and consistency. Which data storage solution is typically used for storing semi-structured data, such as JSON or XML? Is it A, relational databases, B, document databases, C, data warehouses, or D, key-value stores? The answer is B, document databases. Document databases are designed to store, retrieve, and manage document-oriented information, which makes them ideal for semi-structured data like JSON or XML. A logistics company needs to store and quickly retrieve large volumes of time series data from IoT devices. Which storage solution should they consider? Is it A, relational databases, B, document databases, C, time series databases, or D, data lakes? The answer is C, time series databases. Time series databases are optimized for handling large volumes of timestamped data, making them ideal for IoT data. Feature engineering challenges. What is a common challenge when dealing with categorical variables in feature engineering? Is it A, they are always numerical, B, they can increase dimensionality when encoded, C, they are always binary, or D, they require no pre-processing? The answer is B, they can increase dimensionality when encoded. Categorical variables often need to be converted into numerical form for machine learning models, which can be challenging due to the potential increase in dimensionality. Which feature engineering technique might inadvertently introduce bias into a model? Is it A, normalization, B, feature scaling, C, one-hot encoding, or D, data augmentation? The answer is C, one-hot encoding. Why this question may seem a bit tricky. Normalization and scaling are generally neutral, but encoding methods like one-hot encoding can introduce bias if not handled carefully, especially with imbalanced categories. A data engineer is working with a dataset containing missing values in several features. What is a potential challenge they might face when deciding to impute these values? Is it A, the dataset will become smaller, B, the features will become categorical, C, the data will become more complex, or D, the imputation may introduce bias? The answer is D, the imputation may introduce bias. Imputing missing values can introduce bias if the imputation method does not accurately reflect the underlying data distribution. Why is feature scaling important in machine learning? Is it A, to ensure features contribute equally to the model, B, to convert categorical data to numerical, C, to increase the number of features, or D, to remove outliers from the dataset? The answer is A, to ensure features contribute equally to the model. Feature scaling ensures that all features contribute equally to the distance calculations, which is crucial for algorithms sensitive to feature magnitude.
Finding this exam review helpful? If you haven't already, like and subscribe for more videos that'll get you ready to pass.
During a feature engineering process, a team decides to use polynomial features to capture nonlinear relationships. What is a challenge they might encounter? Is it A, the model will become linear, B, the model may overfit the training data, C, the features will be less interpretable, Or D, the computation time will decrease? The answer is B, the model may overfit the training data. Using polynomial features can lead to overfitting, especially if the degree of the polynomial is too high relative to the amount of data. What is a common challenge when dealing with high cardinality categorical variables in feature engineering? Is it A, they are easy to encode using one-hot encoding? B, they can lead to overfitting and increased computational complexity? C, they always improve model accuracy? Or D, they require no special handling? The answer is B, they can lead to overfitting and increased computational complexity. High cardinality can lead to overfitting because the model might learn noise instead of the actual pattern. It also increases computational complexity. Which feature engineering technique might inadvertently introduce multicollinearity into a dataset? Is it A, one-hot encoding? B, normalization? C, polynomial features? Or D, feature selection? The answer is C, polynomial features. Why this question may seem a bit tricky. Polynomial features can introduce multicollinearity because they create new features that are combinations of existing ones, leading to high correlation. A data engineer is tasked with creating features from a time series dataset that includes seasonal patterns. What is a challenge they might face when using lag features? Is it A, lag features can introduce missing values at the start of the dataset? B, lag features always improve model accuracy? C, lag features eliminate the need for other feature engineering techniques? Or D, lag features are not applicable to time series data? The answer is A, lag features can introduce missing values at the start of the dataset. Lag features can introduce missing values at the start of the dataset, which need to be handled appropriately. In a project, a data engineer decides to use feature hashing to handle a large number of categorical variables. What is a potential downside of this approach? Is it A, feature hashing increases the dimensionality of the dataset? B, feature hashing is computationally expensive? C, feature hashing requires extensive pre-processing? Or D, feature hashing can lead to hash collisions, losing information? The answer is D. Feature hashing can lead to hash collisions, losing information. Feature hashing can lead to hash collisions, where different categories are mapped to the same feature, potentially losing information. Data security and governance. What is the primary purpose of data encryption in data security? Is it A, to increase data storage efficiency? B, to protect data confidentiality? C, to speed up data processing? Or D, to ensure data integrity? The answer is B, to protect data confidentiality. Data encryption is primarily used to protect data confidentiality by converting it into a format that is unreadable without a decryption key. In a data governance framework, who is typically responsible for defining data access policies? Is it A, the IT department? B, the data users? C, the data governance team? Or D, the legal department? The answer is C, the data governance team. Why this question may seem a bit tricky. While IT departments implement policies, it is usually the data governance team that defines them to align with business objectives. A company is migrating its data to a cloud service and needs to ensure compliance with data protection regulations. What should the data engineer prioritize? Is it A, encrypting data in transit and at rest? B, reducing data redundancy? C, optimizing data storage costs? Or D, implementing a data backup strategy? The answer is A, encrypting data in transit and at rest. Ensuring data encryption, both in transit and at rest, is crucial for compliance with most data protection regulations. What is a data steward responsible for in a data governance framework? Is it A, Developing data encryption algorithms. B. Designing database architectures. C. Managing network security. Or D. Ensuring data quality and policy adherence. The answer is D. Ensuring data quality and policy adherence. A data steward is responsible for managing data quality and ensuring that data governance policies are followed. During a data audit, it was found that sensitive data was accessed by unauthorized users. What immediate action should the data governance team take? Is it A. Notify all employees about the breach? B. Revoke unauthorized access? C. Conduct a full security audit? Or D. Implement new data encryption measures? The answer is B. Revoke unauthorized access. The immediate action should be to revoke unauthorized access to prevent further breaches. What is the primary role of a data custodian in a data governance framework? Is it A. Defining data access policies? B. Ensuring data quality and consistency? C. Managing the technical environment for data storage? Or D. Overseeing data usage and compliance? The answer is C. Managing the technical environment for data storage. A data custodian is responsible for the technical environment and infrastructure that stores and processes data, ensuring its security and integrity. A data engineer is tasked with ensuring that a company's data pipeline complies with GDPR regulations. What should be their primary focus? Is it A. Increasing data processing speed? B. Implementing data anonymization techniques? C. Enhancing data visualization tools? Or D. Optimizing data storage costs? The answer is B. Implementing data anonymization techniques. The data engineer should prioritize implementing data anonymization techniques to protect personal data, which is a key requirement under GDPR. Exploratory analysis and modeling. Model selection and evaluation. What is the primary purpose of using cross-validation in model selection? Is it A. To estimate the model's performance on unseen data? B. To increase the model's accuracy on the training data? C. To reduce the model's complexity? Or D. To ensure the model is not overfitting? The answer is A. To estimate the model's performance on unseen data. Cross-validation is used to assess how the results of a statistical analysis will generalize to an independent data set. It helps in estimating the skill of the model on new data. Which metric is most appropriate for evaluating a model when the classes are imbalanced? Is it A. Accuracy? B. C. Mean absolute error? Or D. R-squared? The answer is B. F-score. Why this question may seem a bit tricky. Precision and recall are often confused, but F1 score is more suitable for imbalanced classes as it balances both precision and recall. A data scientist is choosing between two models for a binary classification task with imbalanced classes. What should they prioritize in their evaluation? Is it A. Maximizing accuracy? B. Minimizing mean squared error? C. Maximizing F1 score? Or D. Maximizing R squared? The answer is C. Maximizing F1 score. In scenarios with imbalanced classes, metrics like F1 score or AUC-ROC are prioritized to ensure both precision and recall are considered. What is a common method to prevent overfitting in machine learning models? Is it A. Increasing the number of features? B. Using a deeper neural network? C. Reducing the size of the training dataset? Or D. Applying regularization techniques? The answer is D. Applying regularization techniques. Regularization techniques like L1 or L2 are commonly used to prevent overfitting by adding a penalty to the loss function. A team is evaluating a model's performance using a validation set and notices high variance in results. What might be a suitable next step? Is it A. Increase the size of the validation set? B. Use cross-validation for more reliable performance estimates. C. Decrease the complexity of the model. Or D. Switch to a different model entirely. The answer is B. Use cross-validation for more reliable performance estimates. High variance suggests the model may be overfitting. Cross-validation can provide a more reliable estimate of model performance. What is the primary goal of using a validation set in model selection? Is it A. To train the model, B. To evaluate model performance, C. To test the final model, or D. To improve data quality? The answer is B. To evaluate model performance. The validation set is used to tune model parameters and select the best model by evaluating its performance on unseen data. When selecting a model, why might accuracy not always be the best metric? Is it A. It is always the best metric, B. It is too complex to calculate, C. It may not reflect performance on imbalanced data, or D. It requires additional data? The answer is C. It may not reflect performance on imbalanced data. Why this question may seem a bit tricky. Accuracy can be misleading, especially with imbalanced datasets where it may not reflect true model performance. A data scientist is evaluating a model using precision and recall. The model has high precision but low recall. What does this indicate about the model's performance? Is it A. The model is good at identifying positives but misses many actual positives, B. The model is good at identifying negatives but misses many actual negatives, C. The model is balanced in identifying positives and negatives, or D. The model is overfitting the training data? The answer is A. The model is good at identifying positives but misses many actual positives. High precision and low recall indicate the model is good at identifying positive instances but misses many actual positives. Which technique is commonly used to evaluate the robustness of a model? Is it A. Grid search, B. Data augmentation, C. Feature scaling, or D. Cross-validation? The answer is D. Cross-validation. Cross-validation is a common technique to evaluate model robustness by testing it on different subsets of data. In a project, a team is comparing two models using the F1 score. One model has a higher F1 score but lower precision than the other. What does this suggest about the model's performance? Is it A. The model is more precise but less balanced, B. The model has a better balance between precision and recall, C. The model is less effective overall, or D. The model is overfitting? The answer is B. The model has a better balance between precision and recall. A higher F1 score with lower precision suggests the model has better balance between precision and recall, despite lower precision. What is the primary advantage of using a validation set in model selection? Is it A. To increase the size of the training data, B. To provide an unbiased evaluation of the model, C. To test the model's performance on unseen data, or D. To ensure the model is not overfitting? The answer is B. To provide an unbiased evaluation of the model. A validation set helps in tuning model parameters and selecting the best model by providing an unbiased evaluation of a model fit on the training dataset. In model evaluation, why might a high accuracy not always indicate a good model? Is it A. Because accuracy is always a poor metric, B. Because it measures both precision and recall, C. Because it can be misleading in imbalanced datasets, or D. Because it is not a statistical measure? The answer is C. Because it can be misleading in imbalanced datasets. Why this question may seem a bit tricky. High accuracy can be misleading, especially in imbalanced datasets where the model might predict the majority class well but fail on the minority class. A data scientist is evaluating two regression models using RMSE and finds that Model A has a lower RMSE than Model B. What does this indicate about Model A's performance? Is it A, Model A has better predictive accuracy? B, Model A is more complex? C, Model A is overfitting the data? Or D, Model A has a higher variance? The answer is A, Model A has better predictive accuracy. A lower RMSE indicates that Model A has better predictive accuracy on the test data, as RMSE measures the average magnitude of the errors. Bias, variance, and drift. What is the primary cause of high variance in a machine learning model? Is it A, insufficient data? B, overfitting the training data? C, using a simple model? Or D, data drift? The answer is B, overfitting the training data. High variance occurs when a model is too complex and overfits the training data, capturing noise instead of the underlying pattern. Which of the following best describes bias in a machine learning model? Is it A, the model's sensitivity to changes in training data? B, the model's ability to generalize to new data? C, errors due to overly simplistic assumptions? Or D, the model's complexity and flexibility? The answer is C, errors due to overly simplistic assumptions. Why this question may seem a bit tricky. Bias is often confused with variance. Bias refers to errors due to overly simplistic assumptions in the learning algorithm. A data scientist notices that their model performs well on training data but poorly on new data. What is the most likely issue? Is it A, overfitting the training data? B, underfitting the training data? C, data drift? Or D, high bias? The answer is A, overfitting the training data. The model likely overfits the training data, capturing noise and specific patterns that don't generalize well to new data. What is data drift in the context of machine learning? Is it A, the model's inability to learn from data? B, the model's sensitivity to noise? C, errors due to overly complex models? Or D, changes in data distribution over time? The answer is D, changes in data distribution over time. Data drift refers to changes in the data distribution over time, which can affect model performance. During model evaluation, a team finds that their model's predictions have become less accurate over time. What should they investigate first? Is it A, model complexity? B, training data size? C, data drift? Or D, hyperparameter tuning? The answer is C, data drift. Investigating data drift is crucial as it can cause models to become less accurate if the data distribution changes. What is the primary effect of high bias in a machine learning model? Is it A, overfitting the training data? B, underfitting the training data? C, increased model complexity? Or D, improved generalization? The answer is B, underfitting the training data. High bias typically leads to underfitting, where the model is too simple to capture the underlying patterns in the data. Which factor is most likely to cause a model to perform well on training data but poorly on unseen data? Is it A, high bias? B, low variance? C, high variance? Or D, data drift? The answer is C, high variance. Why this question may seem a bit tricky. High variance can cause overfitting, where the model learns noise in the training data, leading to poor performance on new data. A retail company notices that their sales prediction model's accuracy has decreased over the past year. What should they investigate to address this issue? Is it A, model complexity? B, training data size? C, hyperparameter tuning? Or D, data drift? The answer is D, data drift. Data drift occurs when the statistical properties of the target variable change over time, affecting model performance. During a quarterly review, a data scientist finds that their model's predictions are consistently biased towards overestimating sales. What is the most likely cause? Is it A, high bias, B, high variance, C, data drift, or D, overfitting? The answer is A, high bias. Bias in the model can lead to systematic errors, such as consistently overestimating or underestimating outcomes. Hyperparameter tuning. What is the primary purpose of hyperparameter tuning in machine learning models? Is it A, to reduce the model's training time, B, to improve the model's performance, C, to increase the dataset size, or D, to simplify the model architecture? The answer is B, to improve the model's performance. Hyperparameter tuning aims to optimize the model's performance by finding the best set of hyperparameters, which are not learned from the data but set before training. Sarah is using a machine learning model and notices overfitting. Which hyperparameter tuning strategy should she consider to address this? Is it A, increase the learning rate, B, reduce the number of features, C, use a deeper model, or D, apply regularization? The answer is D, apply regularization. Regularization techniques like L1 or L2 can help reduce overfitting by penalizing large coefficients, thus improving model generalization. Which of the following is a hyperparameter in a decision tree model? Is it A, maximum depth, B, feature importance, C, training accuracy, or D, number of features? The answer is A, maximum depth. The maximum depth of a decision tree is a hyperparameter that controls the tree's complexity. John is tuning a neural network and notices it takes too long to converge. Which hyperparameter should he adjust to potentially speed up convergence? Is it A, learning rate, B, batch size, C, number of layers, or D, dropout rate? The answer is A, learning rate. Increasing the learning rate can help the model converge faster, but it must be done carefully to avoid overshooting the optimal solution. What is the role of hyperparameter tuning in machine learning? Is it A, to adjust the weights of the model, B, to optimize model performance by selecting the best hyperparameters, C, to reduce the size of the dataset, or D, to ensure the model is not overfitting? The answer is B, to optimize model performance by selecting the best hyperparameters. Hyperparameter tuning optimizes the performance of a machine learning model by finding the best set of hyperparameters which are not learned from the data. Which of the following is a common misconception about hyperparameter tuning? Is it A, it can be automated using grid search, B, it is necessary for all machine learning models, C, it involves adjusting model weights, or D, it can improve model generalization? The answer is C, it involves adjusting model weights. Why this question may seem a bit tricky. Hyperparameter tuning does not involve adjusting model weights, which are learned from data during training. Emily is using a random forest model and notices high variance in predictions. Which hyperparameter should she adjust to potentially reduce this variance? Is it A, number of trees, B, maximum depth of trees, C, learning rate, or D, minimum samples split? The answer is A, number of trees. Increasing the number of trees in a random forest can help reduce variance by averaging more predictions. Tom is tuning a support vector machine and wants to improve its ability to handle nonlinear data. Which hyperparameter should he focus on? Is it A, regularization parameter, B, gamma, C, degree, or D, kernel type? The answer is D, kernel type. The kernel type in an SVM determines how it handles nonlinear data, with options like RBF or polynomial being suitable for nonlinear relationships. Deployment MLOps. Deployment patterns on AWS. What is the primary purpose of using AWS Elastic Beanstalk in deployment patterns? Is it A, to provide a serverless computing environment? B, to automate infrastructure provisioning and application deployment? C, to offer a fully managed database service? Or D, to facilitate real-time data processing? The answer is B, to automate infrastructure provisioning and application deployment. Elastic Beanstalk is designed to simplify the deployment and management of applications by handling infrastructure provisioning, load balancing, and scaling automatically. In AWS, which service is typically used for blue-green deployments to minimize downtime? Is it A, Lambda, B, AWS Elastic Load Balancing, C, Code Deploy, or D, AWS CloudFormation? The answer is C, Code Deploy. Why this question may seem a bit tricky. AWS Code Deploy supports blue-green deployments, but the term minimize downtime might mislead some to think of other services like Elastic Load Balancing. A company wants to deploy a machine learning model on AWS with minimal management overhead. Which service should they consider? Is it A, Amazon SageMaker, B, Rets, C, Batch, or D, Lambda? The answer is A, Amazon SageMaker. SageMaker is designed for deploying machine learning models with minimal management, providing built-in capabilities for training and deployment. Which AWS service is primarily used for container orchestration? Is it A, CloudTrail, B, Amazon, C, AWS, or D, Amazon? The answer is D, Amazon. Amazon ECS is specifically designed for container orchestration, allowing you to run and manage Docker containers on a cluster. Monitoring and troubleshooting. What is the primary purpose of monitoring in MLOps? Is it A, to automate data preprocessing, B, to ensure model performance and detect anomalies, C, to reduce computational costs, or D, to manage data storage? The answer is B, to ensure model performance and detect anomalies. Monitoring in MLOps is primarily used to ensure that machine learning models are performing as expected and to detect any anomalies or drifts in model performance. A data scientist notices that the accuracy of a deployed model has decreased significantly over time. What should they investigate first to troubleshoot this issue? Is it A, the computational resources allocated to the model, B, the version of the deployment environment, C, data drift in the input data, or D, the model's hyperparameters? The answer is C, data drift in the input data. The first step in troubleshooting a drop in model accuracy is to check for data drift, as changes in input data distribution can significantly impact model performance.
Thanks for watching. If you found this exam review helpful, be sure to subscribe for more real-world practice and topic-focused study videos. And visit Birdsy.ai to start your free trial of Birdsy, your AI-powered study partner.